Hello everyone, welcome back to my channel. I am Jitesh Vonkar, and in this episode we will build an agent that will scale or increase the CPU depending on the situation. So this is the part of the Agentic AI DevOps series that we are following. The problem statement of this episode: when CPU is high, DevOps engineer typically increase CPU limit, may not scale the application, or in some cases scale the application, but it will increase cost. But which one is correct? In this episode we will build an agent that take the decision to that chooses the best action based on the real-time metrics. This is the architecture. So we have Kubernetes cluster, Minikube cluster, and in this episode we are using Prometheus to get the metrics instead of using kubectl top command. We have agent that is in Python. This agent will analyze the CPU or detect the throttling, and based on this context it will take the decision. So we are using Llama 3 with the help of Ollama. The or LLM take the decision. So it will take the decision based on the situation, like it will scale up, it can increase the CPU or do nothing. And once it take the decision, it will call the Kubernetes API to update the deployment. This is the workflow. So as I explained above, we have Prometheus that collect the CPU metrics, AI agent queries the Prometheus API, agent send the CPU data to Llama 3, and LLM take the decision like increase CPU, scale deployment, do nothing, and then agent executes the action via Kubernetes API, and it will stabilize the system. This is the tech stack as I explained already earlier: Kubernetes, Prometheus, Grafana. In this episode, we are not covering Grafana, but in the upcoming episode, we will show you the how the metrics will show in the dashboard. Then we have Python, Ollama, Llama 3, and Kubernetes Python client. So in my previous episode, we have covered how to install Minikube. So if you haven't installed, then you please watch my previous episode. You can start the Minikube using Minikube start. Then in this episode, we are using Prometheus. So you will need to install Prometheus in the Kubernetes cluster. To deploy Prometheus, you can use Helm repo. It will add the repo to the Kubernetes. Then it will then run the Helm repo update. It will update the repos, and finally you can run the Helm install, its monitoring, and Prometheus stack. To verify, you can run the kubectl get-parse command, and it will show the Prometheus and Grafana. We will check that in moment. After you have installed the Prometheus, you can forward the port to access the Prometheus locally. And now we are using the Python. That's why we will set up the environment and then install the required dependencies. Let's first check our agent code. So this is our agent. So it is the same as we have in previous episode. Like we have observer, LLM brain, action, config. Here we are only changing like Prometheus. We are using Prometheus to get the matrix, and now we are completely asking LLM to take a decision. We are not specifying anything to any condition, anything like that. We completely ask our LLM to take a decision. So if you go here and check, so this is the prompt we have written, like you are a Kubernetes performance optimization agent, and we have specified like rule: if CPU is greater than 0.12, then it will scale the deployment. If CPU is between 0.05 to 0.12, then it will increase the CPU, and if CPU is normal, then do nothing. So based on this prompt or LLM, take a decision. So if you come here, so you can see here, we are taking the matrix, and it will print the matrix usage, and then we are directly sending the CPU and prompt to the LLM agent, and it will take the decision what we have to do, and then it will check what is the decision. If it is decision is increase CPU, then it will call this method. If decision is scale deployment, then it will call this scale deployment method, and in interval it will continuously check the Kubernetes pod status. So in the configuration here also we have specifying your Prometheus URL, the namespace, and deployment name. So specifically here, like, we are specifying the guardrails. So like the Kubernetes will scale the CPU limit, CPU, or it will scale the replicas, but it should be a one limit. Like it will only able to, we are based by the guardrail. Like you should be allowed to increase the CPU till 500 M or max 6 replicas, and we are providing 60 seconds as a cooldown period. And every 60 seconds, it will check the status of the Kubernetes pods. And this is the Kubernetes library. So we are using Kubernetes Python library to load the kubeconfig, and then it will perform the Kubernetes operations. And if you come here in the Prometheus, so this is the observer. So we are using Prometheus client library in, and what it will do, this is the query of the Prometheus. So if you see here, this is the container CPU usage total, and we have specifying the namespace. This is the prod, and in every 5 minutes, so it will take the total sum of the CPU utilization in the 5 minutes period, and it will send this query to the we will send this query to the Prometheus to grab the metric. And this is the brain of the LLM, and here we are basically sending the CPU and prompt. So whatever the threshold in the current scenario, and based on the scenario, it will take the decision. So here, like, we have completely depending on our agent to take a decision. Now let's start with the demo. Okay, so like I already clone this repo. So if you haven't, if you have to clone this repo, then please go to this repo. I will provide this link the clone this repo, and this is the steps you will have to follow. So once you clone the repo, first start with the prereq, like you start the Minikube and add the repo, and then once it is done, you can set up the environment and install the dependencies. So I have already done the environment and install the dependencies. So I will skip this step, and now what we will do, first we will create the namespace. So also you can use this Ollama to pull the llama and start the server. I already done this, so I will skip this as well. But you have to run this if you haven't start your Ollama. So first we will create the namespace, that is prod namespace. Okay. Now let's deploy. Now let's go to the path Kubernetes and let's deploy. So deployment is done. Now you can see get pods and namespace prod. You can see 2 pods are deployed. Now let's start the agent, Python agent.py. So now you can see we have CPU usage 0. Now it is just started. So our agent will take the decision like do nothing because it is zero utilization and no action required. Now we have to wait 1 minute because in every 1 minute our controller check the status of the pods. So you can see like it is taking a decision based on the situation because now we don't have any CPU utilization, so we don't need to increase the CPU or scale the deployment. Now we will wait and we are continuously putting the load. So it should increase the CPU because after some time it will put some load to the container. Here you go. Now we have 0.06. Now it should increase the CPU, right? So it is increasing CPU and CPU increase the T100. So now if you come here and check the deployment, so here we have 300 M. So and also you can see here now old terminating and new pods are coming. Now if you come here again we will have to wait for 1 minute and after that it will again check the status of the pod and take the decision based on the CPU utilization. So if you see here like it is waiting. Okay, now you can see here like we have 0.20, so it is more than 0.12, so it will take a decision to scale the deployment. Now if you see it scaled to the 4 replicas. Now if you see here, now we have 4 replicas are running. Mm. So this is the way agent is taking decision, different decision based on the situation. So if you find this useful, then please start this repo and subscribe to my YouTube channel and share your valuable feedback. Thank you.